so let's talk about percent composition. So what is percent composition? So it is the percent of each element in a compound by mass. Okay? And this can be determined from two different ways. The first one is the formula. So the first way I could find the percent composition is from the formula of the compound. Okay. The second way is the experimental mass analysis of the compound. So this is the way that you would do it if you're just kind of doing it on paper and doing a theoretical. This is the experimental way. You would put the compound into a piece of equipment. It actually burns it all up and does combustion, and then it will output your percentages after you put it into the piece of equipment. So obviously we're not going to do that in lecture. So we're going to be using the formula. So what you're going to do is you're going to find the percent of every single element in the compound, or depending on the problem, the one that is asked for specifically. Now one thing I want to remind you of is that the percents, if you find them for all of the elements, they should add up to close to 100, but it might not be exactly 100. So the percent may not always total to 100%. Whoops. And this is usually due to rounding. Now, when I say it's not going to be like exactly 100%, if you get 80%, that's not right. I'm saying you might get 99.98% instead of 100. So it should be really, really close to 100%, but those last couple of decimal places might not be, quite all the way there to be 100.00. All right, but if you're like 95%, that's still probably too far off. So you probably did something wrong with your math. So let's think about how we're going to do this. So if I'm asking for the percent composition of something, if I asked you how to write a percent, if I said, how do you write a percent of something? So say you were in class and I said, all right, what percentage of people in this room have glasses? So you would go around and you would count how many people have glasses, right? And then you would say, so how would you tell the percent? So if I had, in this room, I had 10 people total. 5 of them were wearing glasses. How would you do the percent? You'd say there's 5 out of 10. So 5 out of 10, and then you would divide that, and then you would multiply by 100, and you would get 50%, right? Because 5 divided by 10 would give you 0.5, and then when you did by times 100, you would get 50%. So how we do this is, it is the part, whatever part you're looking for, like the number of people wearing glasses, divided by the whole sampling set. So part would be the number of people in the room wearing glasses, whole would be just the number of people in the room, period, times 100. So that's how we do our fractions and our percents, okay? So to do a percent composition, it's the same thing, but it's for an element, and it's going to be determined by mass. So this isn't going to be just counting people when we do it. We're actually going to be using the mass. So let's look at a problem. That's usually the best way for people to kind of follow this is to do a problem. So this problem says find the mass percent of Cl in C2Cl4F2. So what am I looking for? I want the mass percent of Cl. And so that's a part, and the whole is my compound. So I want to know how much Cl is in that whole thing. Remember, it's a mass percent. So let's kind of write this out. So my mass percent would be the part, would be my Cl, over the whole thing. But I have to take into account how many Cl's I have. So how many Cl's do I have? I have 4. So 4 Cl's over the whole thing. But now we have to say, well, what numbers am I going to plug in? Times 100. It's going to be the mass. So to do this it would be the mass percent is equal to 4 times the mass of Cl. So I'd find the mass of Cl, 35.45. So 4 times 35.45 divided by the mass of the entire thing. So this is where I have to add up the molecular weight. C2Cl4F2. 2 C's, 4 Cl's, 2 F's. Okay? So we go, we look. Here's C, 12.01. Chlorine we said was 35.45. And F is 19, fluorine. So 2 C's at 12.01. 4 chlorines at 35.45. And 2 fluorines at 19. Okay, so we multiply those, add it all up, and we get 203.8 grams per mole. Okay? So that's the mass of the whole thing. So that's the mass that goes down here. So the mass of the part that we're looking for, chlorine, which is 4 times 4 of the mass of chlorine, which is 141.8 grams per mole, divided by the mass of the whole thing, times 100. So when you do this, the part divided by the whole times 100, you get 69.58% is chlorine. Okay? So you do the part divided by that whole times 100. And that gives you the mass percent of just the chlorine. Now you could then go and do the carbon, you could do the fluorine if you wanted, but for this problem it just says the chlorine. Okay? So you did the chlorine and now you're done. Alright, on the next lecture we're going to do another problem on mass percent.